So let's look at some examples. In these few examples, we are being told that each figure is a parallelogram. So all those properties apply, and we're supposed to identify the special type. So is it a rectangle, a rhombus, or a square? And explain our reasoning. Looking at our first example, we see diagonals marked, and we also see that diagonals are bisecting each other. That is true for all types of parallelograms, but we do see that those diagonals are perpendicular. Let's put this down. And if you look back at your list of properties, or you have them memorized already, then you remember that polygon where diagonals are perpendicular is a rhombus. So this has to be a rhombus. In our next example, we are not given a lot of information. We are only told that these two sides that are next to each other are congruent and there's a right angle. Now, knowing that this is a parallelogram, that means that the opposite side has to be congruent also. And if we mark all opposite pairs of sides, we see that all four sides actually are congruent. And now we're going to mark our opposite angles congruent, which is also true for parallelograms. We have two right angles already, and now angles consecutive and next to each other have to add up to 180. 90 plus 90 is 180, and that gives us four sides that are congruent and four angles that are congruent. All sides are congruent, all angles are congruent, and you know what that means. This has to be a square. Moving on to our third example here. All we have one angle given, that's a right angle. So we're going to mark our opposite angle as congruent, which makes it a right angle as well. And now we're going to look at our consecutive angles. The angles next to each other have to be supplementary and add up to 180. 90 plus 90 is 180. And making the other two consecutives 180, or the two angles across from each other congruent. Either way, we figure out that all angles this time are congruent, and they're all 90 degrees. And what that means is we have a rectangle. Now mark you that this rectangle might be a square. We don't know anything about the sides. It can be a square, maybe it's not, but it is definitely a rectangle because all four angles are congruent. And as we have said many times before, note that when you mark your diagrams with all the things that you are given or that you have found yourselves, additionally, it makes it way easier to then come up with an answer and with the reasons for the answer that you are giving. In our next example, the diagonals of rhombus WXYZ intersect at V, and given that the measurement of angle XZY is 34 degrees and WV is 7, find the indicated measure. So our angle XZY is 34 degrees. This has already been marked, and V and WV is 7, which has also been marked. So given that this is a rhombus, and this is what we're being told, we know that the diagonals bisect the angles. So if this diagonal bisects this angle and cuts it into two equal pieces, if this half is 34 degrees, that means that this half also has to be 34 degrees. And as a matter of fact, we know that the two opposite halves also have to be 34 degrees. We also know that In any parallelogram, diagonals bisect each other. So if this diagonal is bisected by the other one, WV is 7, then VY also has to be 7. And now let's see what is one of the things that we're being asked here. We're being asked the measurement of angle WZV, and WZV is this angle. And as you can see, we have already found it. It is 34 degrees. Next, we were supposed to find the side ZY. The side ZY is down here, and we're supposed to find it, but we have no information about sides at the moment. So we have to do something else. We have to look for other familiar shapes. And as you can see in here, and if you look a little more closely, you see that we do have a triangle, and one of the sides we know the length of, and we're supposed to find the length of ZY. This is the one we don't know. And maybe it'll be easier if we just make a separate drawing of that triangle and see what are the things we have and what are the things we need. We have this side length of 7 and this angle of 34 degrees, and we're looking for this side down here. How do we find this? And if you were thinking, so Katoa, good for you, because that is exactly what we're going to use to find our missing side length. We have an angle and we have the opposite side, and we're looking for the hypotenuse, so we're going to use the sine. The sine of 34 degrees is equal to 7 over our missing side. I didn't use variables this time because we have already used so many variables for the angles of our parallelogram. We solve this by multiplying both sides by our question mark and then dividing by the sine. They essentially switch places, and our missing side is 7 divided by the sine of 34 degrees. Now make sure that your calculator is in degree mode and punch the numbers in, and the answer will be that this is approximately 12.5. So the length of ZY is approximately 12.5. In our next example, the diagonals of rectangle PQRS intersect at T. Given that the measurement of the angle RPS is 62 degrees and QS is 18, find the indicated measures. So let's first again mark what we have. We have the measurement of angle RPS, and that is 62 degrees. And if this angle is 62 degrees and we have a rectangle, that means that this angle is 90 degrees. So 90 minus 62 is 28. So we know that the smaller of the two angles here has to be 28 degrees. And since we know that all 4 angles of the rectangle have to be right angles, and the 2 angles they're cut into are alternate interior angles from each other, we know that this one has to be 62 degrees and the alternate interior to that one is 28 degrees, and the same is true for the remaining angles. And now we have marked all angles with their measurements. We are also told that QS is 18. The length of the diagonal QS is 18. That means, since the diagonals bisect each other, that the 2 halves are 9. And since both diagonals are also congruent, and that is specifically for a rectangle, we know that the other diagonal, PR, also is cut into 2 equal pieces of 9 units each. And now we can see what we have found and if that answers the questions we had. The measurement of angle QPR, we have found QPR is 28 degrees, and the length of segment ST down here, half of the diagonal SQ, is equal to 9. And see how you had everything marked in your diagram, and that gave you the possibility to just read the answers of your diagram. Let's go to our last example of the day. The diagonals of square EFG intersect at J, and given that GJ is 15, find the indicated measure. So this being a square, we know that just like in a rectangle, all angles are right angles. All 4 angles are congruent and they are right angles. And furthermore, we know that they are being cut into equal pieces. And we also know that the 2 diagonals are congruent and therefore are being cut into 4 equal pieces. And that means that all 4 pieces have to be 15 units long. And all this we know because a square has the same properties as a rectangle. But a square also has the same properties as a rhombus, and that tells us that the 4 sides have to be congruent, and it also tells us that the 2 diagonals meet each other at a 90-degree angle, and in other words, they are perpendicular. So now let's look what we're being asked. In number 8, we're being asked the measurement of the angle EJF. EJF is this angle, and we just figured out that that angle has to be 90 degrees because the diagonals are perpendicular. Excellent. And furthermore, we're supposed to find the length of segment FH. Segment FH is this diagonal, and the diagonal is made up by the 2 pieces that are congruent, 15 units long each. 15 plus 15 is 30. All right, that's it for today, and I will see you in class.